Hello everyone, this time I will discuss materials about permutation in the form of animation. Introduce, my name is Chelsea Emely Mawikere, final number 02, Information System Class A.
Good morning to all. Today we will learn about permutations. Previously, did anyone understand and could explain what a permutation is?
I don't understand the teacher yet.
Well, it's okay, I'll explain a little bit what permutation is. A permutation is a mathematical calculation of the number of ways a given set can be arranged, with the order of the arrangement in mind. Permutation means the number of possibilities to select a certain number of objects from a larger set. The trick is to multiply the number of choices of selecting an object by the number of choices of the next object drawn, and so on. Permutations are divided into several types: permutations of different elements, permutations of the same elements, cyclical permutations.
Can permutations be used in everyday life, ma'am?
Permutations have wide applications in everyday life, although they may not always be realized directly. Such as some examples of the use of permutations in daily life: travel routes. When planning a trip from point A to point B, there are various possible routes that can be taken. Each combination of different roads or modes of transportation can be considered as a permutation of a travel route. Organizing schedules. In organizing a daily or weekly schedule, we often organize activities in different orders. For example, the order of doing household chores, working, hanging out with friends, or exercising can be considered as permutations of existing activities. Queue order. When queuing at places like supermarket checkouts, payment counters, or event entrances, the order in which customers or attendees queue can be thought of as different permutations depending on who arrives first or last.
Thank you, ma'am.
Well, please pay attention. The teacher will explain examples of different element permutations, same element permutations, and also cyclical permutations. Pay attention all to the blackboard. 1. Permutations of different elements. A permutation with different elements means that the elements to be arranged are all different. The calculation of the number of elements from n available elements is usually written as pkn or npk or pnk. Here is the formula for different element permutations. npk equals n factorial division nk. Description: n equals number of elements available equals the number of elements to be arranged. Read factorial equals n multiplication n1, n2, n3. Example: in an organization, the chairperson, treasurer and secretary will be chosen from 8 candidates who meet the criteria. The number of possible management arrangements of the 8 candidates is known. N equals 8, k equals 3 asked, 8p3 equals completion. 8p3 equals 8 factorial division 8 minus 3 factorial 8p3 equals 8 factorial division 5 factorial 8p3 equals 8 multiplication 7 multiplication 6 multiplication 5 factorial division 5 factorial 8p3 equals 8 multiplication 7 multiplication 6 8p3 equals 336. So the possible management arrangements are 336 ways. 2. Permutation of same element. A permutation of equal elements is an arrangement of a group of objects where there are similar objects. Suppose out of n elements there are k1, k2, k3, kt same elements. The formula for permutation of same elements: np k1, k2, k3, kt equals n factorial division k1 factorial multiplication k2 factorial multiplication k3 factorial multiplication. Factorial. Example: the number of different arrangements of the letters in the word mathematics is equal to unknown, n equals 10, m equals 2, I equals 3, t equals 2, e equals 1, I equals 1, k equals 1 asked, 10p2, 3, 2, 1, 1, 1 equals. Solution: 10p, 2, 3, 2, 1, 1, 1 equals 10 factorial division 2 factorial 3 factorial 2 factorial 1 factorial 1 factorial 1 factorial 10p 2, 3, 2, 1, 1, 1 equals 10 multiplication 9 multiplication 8 multiplication 7 multiplication 6 multiplication 5 multiplication 4 multiplication 3 factorial division 1.2.3 factorial multiplication 1 multiplication 2 multiplication 1 multiplication 1 multiplication 1 10p 2, 3 2, 1 1, 1 equals 604,800 division 410p 2, 3 2, 1 1, 1 equals 151,200. So the number of arrangements of the word mathematics is 151,200 ways. 3. Cyclical permutation. Suppose there are 4 people sitting around a round table. Then the circular permutation of the 4 people can be described as follows. Note that in the above circular arrangement there are 6 ways for the 4 people to sit. So out of n different elements arranged in a circle. Cyclical permutation formula, psychic equals, and 1 factorial. Bella has 7 colorful baubles to be arranged on a bracelet. The number of ways Bella can arrange the baubles on the bracelet is unknown. N equals 7. Asked, psychic equals. Solution, cyclis equals 7 minus 1 factorial cyclis equals 6 factorial cyclis equals 6 multiplication 5 multiplication 4 multiplication 3 multiplication 2 multiplication 1 cyclis equals 720. So, the number of trinkets in the bracelet is 720 ways.
Thank you.